All right, guys, so we're going to start reviewing for the third test of the third quarter. For number 1, convert the radian measure into degrees. We have 4 pi over 3. To put this radian into degrees, you would replace the pi with 180 because, again, pi radians is 180 degrees divided by 3. You can type that directly into the calculator. That'll give you 240 degrees. For number 2, to go the other way, convert the degrees into radians, you would multiply by pi over 180, because again, those are the same thing. So it's kind of like you're multiplying by 1. And then in the calculator, you would do 315 divided by 180 and clean that up. So 315 divided by 180 is 7 over 4. And then you throw pi back in the top. For 3 through 6, the evaluating, you are going to make sure you're in the correct mode. So usually it's going to be in radian mode unless you see that degree symbol. So 3 through 6, all 4 of these are all in radians. For number 3, we have 2 times the sine of 3 times 3 pi over 2 minus 4. So you're not going to type the whole thing in. You're only going to type this piece in, just in case it's one of those special decimals before you multiply it by 2 or subtract 4 and change whatever the decimal is. So when you type this into your calculator, you're going to get a 1. So you have 2 times 1 minus 4. That's 2 minus 4 is negative 2. You'll clean it up by hand because, again, your directions say exact value. For number 4, 5 minus 8 times the tangent of 4 times pi over 6. So again, you're not going to type the whole thing in. You're just going to type in tangent of 4 times pi over 6. When you type that in, that gives you negative 1.7320, blah, blah, blah. That's one of your special decimals. That special decimal is the square root of 3. Okay, so then to clean this up, you have negative 8 times negative square root 3 is plus 8 square root 3. And that's your answer. You're not going to write that as a decimal because, again, the directions want exact value. For numbers 5 and 6, I give you the reciprocal functions. So here, you would plug this into the calculator, but except you can't plug secant into the calculator. What you can plug in instead is the cosine, which is the reciprocal of secant. So you would do cosine of 3 pi over 4 plus pi. When you plug that into the calculator, that gives you the square root of 2 over 2. It really gives you 0.7071, which is the square root of 2 over 2. So when you're filling this in, this is going to be the reciprocal of the square root of 2 over 2, which is 2 divided by the square root 2, minus 4. Now, whenever we give our answers, we want to make sure that our denominators are all rationalized, meaning that there's no square root. So you multiply the top and the bottom by the square root of 2. That gives us 2 square root 2 over 2, which is really just the square root of 2, minus 4. Chances are, though, if this were this is an acceptable answer, but a multiple choice answer will probably put the square root at the end, just because typically we usually write the radicals at the end. So this would be negative 4 plus the square root of 2. And then the last one for this is number 6. 6 times the cosecant of 4x over 3. So again, you can't type the cosecant in, but you can type the sine in. So you would do sine of 4 times pi over 2 over 3 into the calculator. That would give you 0.8660, which is the square root of 3 over 2. But remember, I don't want the sine of 4x over 3. I want the cosecant of 4x over 3. So I'm looking for the reciprocal, which would be 2 over the square root of 3. This gives me 12 over the square root of 3. But when I rationalize it, that is 12 square root 3 over 3. Final answer in simplest form would be 4 square root 3 for number 6. For number 7 and 8, determine which quadrant the terminal side lies in. So this is your all students take calc. And remember, the reciprocal functions follow the same order. So for number 7, cosine of theta is less than 0. Cosine theta less than 0, that's in quadrant 2 and quadrant 3. Sine of theta greater than 0, that would be in quadrant 1 and quadrant 2. So final answers to this would be quadrant 2. Okay. Number 8, cotangent of theta is less than 0. Cotangent of theta is less than 0, where tangent of theta is less than 0, so that would be quadrant 2 and quadrant 4. Secant of theta is greater than 0. That's where cosine is greater than 0 in quadrant 1 and quadrant 4. So answer to 8 is quadrant 4. Number 9, verify the following identity for when theta is equal to 3 pi over 4. So whenever you're verifying an identity, you're going to, for a specific theta value, you're going to plug in that theta value and just show that everything is true without a doubt. And you pretty much want to do this by hand. So the cotangent, you're going to plug in 3 pi over 4 for theta. So you do cotangent of 3 pi over 4 squared equals cosecant of 3 pi over 4 squared minus 1. Cotangent, again, you can't type cotangent in, but you can type in the tangent. Tangent of 3 pi over 4 is negative 1. The reciprocal of negative 1 is negative 1 squared equals, when you try to do the cosecant, you have to plug in the sine of 3 pi over 4. The sine of 3 pi over 4 is 2 divided by the square root of 2 squared minus 1. You can rationalize that if you want, or when you go to square, the radical is going to go away anyway, so you really don't have to. Negative 1 squared is 1 equals, to square this, 2 squared is 4 over the square root of 2 squared is 2 minus 1. So 1 equals 4 over 2 is 2 minus 1. 2 minus 1 is 1. You have to finish until it's like without a doubt that's definitely true. Number 10, using the Pythagorean identity, determine the exact value of cosine in simplest form if sine of theta is 3/4 and we're in quadrant 2. So there are different ways that you could solve this for cosine theta if you wanted to draw that picture and like list all of them. But because this says using the Pythagorean identity, you have to use the specific way. The Pythagorean identity says that sine squared theta plus cosine squared theta is equal to 1. And it gives you that sine of theta is 3/4. So we have 3/4 in for sine of theta squared plus cosine squared theta equals 1. 3 over 4 squared is 9 over 16 plus cosine squared theta equals 1. When you subtract the 1, now you have cosine squared theta is equal to, when you subtract the 9/16, 1 minus 9/16 is 7/16. And then you go to take the square root of both sides. So you get cosine of theta equals, whenever you take the square root, you have plus and minus. The square root of 7 is the square root of 7. The square root of 16 is 4. So cosine of theta could be positive square root 7 or positive square root 7 over 4 or negative square root 7 over 4. But because of this piece of information that we're in quadrant 2, right? Quadrant 2, cosine is negative. It has to be that cosine of theta is negative square root 7 over 4. It has to be that. For number 11, the tangent of theta is less than 0 and cosine of theta is negative 12/13. Find everything else. So tangent of theta less than 0. Cosine of theta is negative. So they're both negative. That means that we are in quadrant 2. So I draw an angle in quadrant 2. I go straight to the x-axis. This is my right angle. This is theta. Cosine of theta that rule is adjacent over hypotenuse. So adjacent to theta is 12. The hypotenuse is 13. Now your hypotenuse is always positive, but remember, this is your origin right here. Because you go back to the left, this is actually a negative 12. So to figure out your missing side, you do the Pythagorean theorem. You do negative 12 squared plus x squared, because we're looking for a leg, equals 13 squared. That is going to give you x squared is equal to 25. So x is equal to either positive or negative 5. Because we go up, it's going to be the positive 5. So then to figure out all of the ratios, you just do SOHCAHTOA pretty much on that picture. Sine of theta is opposite over hypotenuse, 5/13. Which means that cosecant of theta, its reciprocal, is 13/5. We know that cosine of theta is negative 12 over 13 from the question. Secant of theta is negative 13 over 12. Tangent of theta is opposite over adjacent. So 5 over negative 12, or negative 5 over 12, same thing. And cotangent is that reciprocal, which would be negative 12 over 5. Number 12, find the exact value of all 6 trig functions of theta in standard position if its terminal right intercepts the point 6, negative 4. 6, negative 4 is in quadrant 4. So you draw an angle going out, you go straight to the x-axis, this is your right angle, and this is theta. So this here is the point 6, negative 4. So you go over 6, down negative 4. So that takes care of what's positive and negative for you. And then to figure out your hypotenuse, you plug it into the Pythagorean theorem. So you would do, you're looking for the hypotenuse, so you're looking for C. 6 squared plus negative 4 squared equals x squared. That would be x squared is equal to 52. So when you take the square root of 52, your hypotenuse is always positive. The square root of 52 you can actually clean up. 52 is 4 times 13. So the hypotenuse is 2 square root 13, always positive. Okay, so then to figure out all 6 trig functions, sine of theta, sine is opposite over hypotenuse, opposite over hypotenuse. We'll do cosecant is the reverse of that. Negative 2 rad 13 over 4. We'll clean all these up after. Cosine of theta is adjacent, which is 6, over the hypotenuse. Secant of theta is the reciprocal of that, so 2 rad 13 over 6. Tangent of theta is opposite over hypotenuse, and cotangent of theta is the reciprocal of that. Okay? Tangent of theta is opposite over adjacent, not hypotenuse. So now to clean these up, so negative 4 over 2 rad 13, what you can do first is make this negative 2 over the square root of 13, and then when you rationalize, you get negative 2 rad 13 over 13. For cosecant, the 2 and the 4 can be simplified. That would be negative square root 13 over 2. For cosine, that would be 3 divided by the square root of 13. Have to rationalize that, so 3 square root 13 over 13. Secant would be the square root of 13 divided by 3, right? 2 over 6 becomes 1 over 3. Tangent would be negative 2 over 3, and cotangent negative 3 over 2. And 13 are graphing. So 13 and 14 we are graphing. So we're graphing on 0 to 2 pi for both of them. Okay, so first what I asked you to do, what I think would be helpful, is if you label the amplitude, the midline, the range, and the period. So the amplitude is 1, the midline is y equals 2, the range would be from 1 until 3, and the period is 2 pi over 3. If this equation bothers you, if the 2 out in front bothers you, just put it to the end. But the 2 is your midline. Okay, y equals 2 is the midline. So then when you're going to graph this, we're going from the midline is 2. We're going up by 1, down by 1, and then 1, 2, 3, 4 slashes is 2 pi over 3. Have to make it to 2 pi though. So I go again, 1, 2, 3, 4. Now is 4 pi over 3. Another 4 is 6 pi over 3, and 6 pi over 3 is 2 pi. Now remember, when you're graphing, you are graphing only between the max, the midline, and the min. Okay? For a sine function, a positive sine function, the y-intercept is on the midline, and because it's positive, then you go up, midline, down, midline. This represents one cycle, and then you just continue with this pattern until you get till the end of your slashes. Oop, that looks awful. Make sure your graphs are nice and curved, that they're hitting all of your points. So obviously my graph is not really great, but that would be it. 14, same deal. We have our amplitude is 3. Our midline is y equals 5. The range, so you're going from 5, you're going down 3 to 2, and up 3 to 8. And then the period is 2 pi over 2, the b value, which is just pi. So this function, the minimum is 2, 5 is your midline, 8 is your max. So again, you're only graphing lines on these, you're only graphing points on these 3 lines. For your x-axis, 4 slashes is the period. 1, 2, 3, 4. The period is pi. We're graphing from 0 to 2 pi, so we go again. Now we're at 2 pi. This is a negative cosine graph. Cosine always starts at the max or the min. Because this is a negative cosine, it starts at the min, and then your next slash is on the midline, next slash is on the max, and then the midline, and then the min. This is one cycle of this cosine graph, but then you keep graphing it until you complete what the question wants, what the domain wants, which would be from 0 until 2 pi. Okay, again, nice and curved graphs should look better than mine. Number 15, element X is a radioactive isotope. It's every 25 years, its mass decreases by half. This is a half-life question. Your half-life formula, A equals P times 1/2 raised to the time divided by H. Given that the initial mass is 60, how long it would take to reach 28? So 28 is A, 60 is P, 1/2. We're solving for the amount of time, which is T, and the half-life, every 25 years, its mass decreases by half, so that's why your half-life is 25. So first, you're going to divide both sides by 60. 28 divided by 60 gives me 7/15 equals 1/2. If you want to write that as a decimal, you can. Just remember not to get rid of that number in the calculator. You need the entire decimal. So then you take the log of both sides. So log of 7/15 is equal to time divided by 25 log of 1/2. Divide both sides by the log of 1/2. That way it cancels over here. Which gives me 1.09958 equals time divided by 25. I cross multiply and I get time is equal to, round it to the nearest tenth, 27.5 years. And then last question, James invested $1,100 in an account paying an interest rate of 2.65% compounded quarterly. So this is your compound interest formula. A equals P times 1 plus R divided by N raised to the NT. We are again determining how long it would be. We're solving for T again. So A, we want it to reach 1850 equals P is 1100. 1 plus R, move the decimal over twice, 0.265, divided by N, it's compounded quarterly, so that would be 4, raised to the 4T. First step, you divide both sides by 1100. This cancels. 1850 divided by 1100 gives you 37/22. Again, if you write that as the decimal, that's fine. Equals 1 plus. You take the log of both sides, so the log of 37/22 equals 4t log 1 plus 0.0265 over 4. Divide both sides by the log of 1 plus 0.0265 over 4. That cancels on the left, gives us just 4t. I'm sorry, on the right. And then on the left, when you divide that, you get 78.73141 with a whole bunch of decimals. And then in the calculator, you just divide by 4. And we're rounding to the nearest hundredth of a year, giving us 19.68 years. Okay? Any questions? Extra help will be after school on Thursday, March 12th. Have a good day.